So let's talk a bit about DevOps and DevOps at scale. And since Andrei mentioned Baruch, Baruch is a co-creator of this talk. We collaborated on it. This is the second time I'm delivering it by myself. I'll try to do both parts as well as we do it together. There are a few videos on the internet. We want to talk a bit about DevOps and what does it take to scale DevOps to a substantial scale. And as Andrei has alluded, I've run some of the largest engineering and product operations teams, at least in this pure play SaaS space at companies like Taleo and Oracle. We've also done a lot of research about this space at CA, where I run engineering for our APM product. And if you know companies like New Relic, AppDynamics, those are the companies that came out of the CA team that started APM when Wiley was created as a business. Now, to make it a bit more fun, we're going to present it as a Greek tragedy in 3 acts. Who knows what's the key element of a Greek tragedy, of a good Greek tragedy? And I'm just going to stand here, wait till somebody answers. This is how it's going to work. So anybody? Does anybody know? Anybody studied literature, remembers literature from high school perhaps? Key element of a Greek tragedy is everybody dies, right? They all have to end like that. Having said though that, this talk was written for US market initially, so there will be a happy ending, so don't despair. So let us begin. I talked a bit about myself. If you want to follow me or tweet about this talk, especially to tell me how horrible the content is, you can find me on Twitter at LIGOLNIK. It's the good news, include my nick. If you wanna disparage the talk, please make sure you include Baruch at jbaruch, because he would love to hear from you as well. This is the boring slide, and since the legal team that used to be part of the company I used to work for is no longer here, we can skip that. But before we do, I wanted to ask folks in the audience, what type of work do you do? Who here is a software developer by day and by profession? All right, a good chunk of you. Anybody works in DevOps or operations, running software? Okay, 2, 3, 4. This is 400% increase on Odessa. Anybody in team leadership or management or project leadership? Okay, 4. Okay, so at least 5 people may find this talk interesting. Good. So let's talk about DevOps. What the hell is DevOps, right? And because Greeks loved Venn diagrams, we will try to look at DevOps as a Venn diagram. Not as ancient as this one, but maybe as modern as this one, right? There's a traditional view of DevOps being development, operations, and QA, and DevOps being squarely at the intersection of those 3 dimensions, right? Why is it called DevOps? Well, it started by the operations guys. They started talking about developers. They forgot about QA. It was too late to change the name, right? They remembered that quality and testing is kind of important, but it was too late. Anybody here is software engineer and test or focuses on things like quality in projects? Performance, scalability testing maybe? Okay, at least one person. Good. Now, that's the traditional view of DevOps. In the talk, we will also take another set of dimensions and look at DevOps from a different perspective as an intersection of technology, people, and process, which are the things that we often forget when we as teams or as leaders in organizations try to adopt DevOps. And we're going to do it by reliving a story or inception to death, perhaps, of a mythical company called Pentagon Inc. And we'll talk a bit about Pentagon later on. But let us begin. And like a good tragedy in 3 acts, we'll start with Act 1, the Fire Brigade, also known as Reactive Operations. So to set the stage, let's see what the company is. So we have 3 developers. It's a new startup that 3 guys have started. They quit their corporate jobs. They decided, you know, we're going to do something together, something more fun. They all come from an on-premise background. Perhaps that's why the company is called Pentagon, or perhaps it's called Pentagon because they're trying to compete with another company that does payment processing, which is what they do. It has a slightly different geometrical shape to them, a company called Square, right? Now, those guys, even though they came out of defense, they came out of on-prem background, they're fairly smart people, right? But they're kind of hipsterish. They go to conferences. They felt constrained in their old corporate jobs. So the technology stack that they picked up is JavaScript, Node, Reactive, microservices, all the buzzwords you've been hearing in conferences, they got. But they're doing it quite well. So that's the company in Act 1. Let's see what's going on in process. Well, what kind of process can they be when they're 3? Well, they're doing Kanban. Could be on Trello, could be in Jira, could be on the whiteboard, could be with sticky notes, who cares, right? There are 3 of them. They can get together in the room, talk it out, and decide what to build. Quality, again, I mentioned to you guys, those guys are competent engineers, so they started day 1 with things like TDD, unit and integration tests, like CI is actually executing the test. Everything's done right. Ops, well, for the ops guys in the audience, what ops? Right? They heard that this lovely thing that is very popular right now, it's called serverless. Naturally, we don't need any ops guys, right? Like, who needs them anymore? Plus, you know, all they remember from their historical background from working in their previous company about ops is ops used to be an obstacle. So of course, the 3 of us, freedom, everybody has root. That's great, right? Tools, also very simple. Jira, GitHub, I assume you guys know those. Anybody here heard of Travis CI? Okay, actually more than normal, that's good. So Travis CI, for those of you that haven't, is just Jenkins in the cloud. It's one of the competitors. It's a CI server, runs in the cloud because those guys are serverless, monitors GitHub for code changes, and just does the usual stuff, runs the test suite because they have one, and moves everything to, in their case, AWS Beanstalk, right? Beanstalk is a lightweight orchestration for deployment, so very simple tools. Well, let's see what happens. So like a good startup, you know, what do you do first? You mostly focus on building the product, building the product, building the product, and then waiting for that first customers. And in our case, those guys got lucky. They managed to secure a business from one of the biggest names in personality celebrities. Let's say it was Kim Kardashian. She chose them to do payment processing for all of her online properties. Pretty big, right? Lots of traffic, well-known personality. Now, if you're a startup that scores a big customer, right? You have no funding, you work for a long time. What do you do first? You celebrate, right? Lots of alcohol. And please note this slide, it may come back in other acts. There are certain patterns to what happens as you evolve, but you celebrate. That was Thursday. You know, the customer goes live, and then the usual thing happens Friday night. The founders get called from the customer, and the answer goes, nothing works, right? And then you go, oops. The first thing you get that happens when you get a call like that on Friday in the middle of the night from a big customer you just scored is what? You panic. You panic for a while. So let's observe this slide. And then, you know, then you charge. Got to go figure out what the hell happened, right? But it's all easy, right? We all have root. We all can get on a conference call. It's middle of the night. It's 2 a.m. We still partied on Friday. People are lightly drunk, but that's okay. We've got root, let's go see what's going on. Wait, where are the logs? We have like 26 microservices. Does anybody know where the logs are? Oh, yeah, they're in some other console on AWS. Maybe well aggregated, maybe not, because like, you know, no ops, who needs ops? Where's the actual log where the error is happening? Because I see an error here happening at 2 a.m. in the morning, and there's another microservice over here, and the error is happening at 4 a.m. in the morning, and it seems to be the same transaction ID. What the hell is going on? Well, that, my friends, is called time zone acrobatics. If you ever tried to troubleshoot a production system, anybody experience that? When the servers are not set to the same time zone? Ain't that awesome? Yeah. Nothing better to do in the middle of the night than try to calculate offsets between different logs and different servers because you're trying to correlate what the hell happened in a complex system. Well, they figure out after some hard work in a few hours that the issue was broken by a commit. We have a mythical figure in our talk. We'll call him Billy or Vasya, depending on the context. Vasya had this brilliant idea Thursday night. You know, after the party, after the first customer went live, who cares that he was drunk? He committed it. CI passed, testing passed, everything was peachy, went straight to production. Clearly there was a bug, but let's not despair. We have a build. We can reproduce the previous build. Let's roll back. Wait, it doesn't build. Damn it. It says the component is missing. How could that be, right? We just rolled back one commit. How could a component be missing? Anybody here heard of this thing called NPM gate or unpublished gate? At least a couple. Okay, so for the rest of you, I'll tell you the story. So if you're doing stuff in JavaScript and NPM, I know this is a Java user group, but you know it happens to the best of us. There's this library in Node, very popular one called leftpad. It's like 15 or 17 lines of code. Really, really like useful thing. As the name would imply, it allows you to leftpad content with spaces or whatever else you need to. About a year and a few months ago, the author of leftpad got really upset with the community and unpublished the library from the repository. That day, half of the internet went down, or at least couldn't release any software anymore, at least the ones that were at this stage of reactive ops, because they couldn't build anymore. There was a missing module, right? So there's a lot of hard work. They find a copy of the leftpad thing, and they paste it into a custom piece of code, and they build the software, and by 6 a.m., they get the customer up and running, right? And unfortunately, nothing else changes at this stage of the company, right? There's a lot of hard work, time after time, fire drill after fire drill. This continues because those guys, there's 3 of them, right? And they continue to grow the company. And I'm sure all of you have worked at the company that either was in that stage or hopefully successfully left that stage. Because if you stay in that stage of hard work and constant fire drills, forever, you typically do not survive as a company, right? So that's our little first act. Let's talk about Act 2. Act 2 is called smoke alarm installers, also known as reactive operations, right? Slightly different way of running your process. Let's see what happened. So let's set the stage. People, well, the company has survived, they've grown a bit. They hired 26 more engineers. They closed round A. They hired this one human being, a dude, that has an ops background. They kind of realized this whole ops thing, serverless, just means somebody else's server. We actually need somebody who understands what it is to operate a production environment at scale. They've gotten to about 100 customers, pretty decent for a startup at round A. They have a support team now, right? They got tired of answering customer calls, plus, you know, let's be honest, we engineers suck at answering customer calls. So they hired a small support team. Their process naturally had to evolve because there are 26 plus the 3 original guys plus the ops guys, like 30 people. You can't run Kanban anymore, at least not successful, or at least not very many teams are able to run Kanban at 26 or 30 engineers. So they switched to Scrum, or maybe like a Scrum bun. We can talk a bit about that in Q&A. Who knows what exploratory testing is? Okay, yes, at the back there, unfamiliar face. What is exploratory testing? Yes. Well, you raised your hand, so. Excellent. In a nutshell, a better name for manual QA. With methodology. Now, realistically, you know, TDD and automated tests don't cover everything, so they realized that it's a business application. They hired somebody who understands the methodology of how to exercise the application and get the right type of coverage. Plus, that person becomes the advocate for testing and TDD or test-driven development-like processes for the rest of the team. Ops, well, they got a dude that knows that stuff, right? So, you know, they now have ops. They have this thing called the developer on call. Anybody here goes on call or used to go on call every once in a while? Only one. Wow, that's way lower than normal. So the job of the developer on call is to be available with one of those devices, probably a laptop, on a 15-minute notice, on a 24/7-hour basis. Hopefully you were not the sole person on call. Hopefully it was a rotation. I've seen teams where there's like one dude that goes on call. That kind of sucks. In their case, it's a weekly rotation. Everybody goes on call. Why? Well, because pain is instructional. I know that nothing made me write better software and better logging than waking up at 2 a.m. in the morning on Friday. You may notice a theme. It's always happening on Friday. It's always 2 a.m. and I'm always drunk, even though I'm on call. And working for 2 hard hours instead of 15 minutes, only if I just put the right log message in the code, right? Sometimes pain is instructional, so they have this guy. The other job of the developer on call at this stage is to get interrupted so the rest of the team doesn't have to, right? If there's an emergency, the support team will reach out to the engineer on call. It's very painful. Every team that I brought on call as a process to as the engineering leader doesn't like it, and yet they've realized through this process of exposing themselves to a bit of the pain, the software ultimately becomes better. They figured out the whole log aggregation stuff, right? They got a system for that. And, you know, they put the clocks where the clocks belong. They put them in UTC on every single server. Does anybody know why UTC and no any other time zone? There's no daylight savings. And that's very important because it's amazing what happens when you hit a bug that happens during daylight savings and the clock moves back and you have 2 log messages that happen past 11:28 a.m. How could that happen? Well, the clock rolled back by an hour, right? That's why not GMT, because GMT also has daylight savings. UTC is the time zone you keep your servers. That's the clock that never moves. Kind of useful. You know, they considered moving their servers to England, but they realized it's a bit more expensive there, so they kept them in Amazon where they used to be. Obviously, the tool chain had to evolve as well. Because they have the support team and the developer on call, they got in some kind of knowledge base at that stage. In our case, it's Confluence, can be any other wiki implementation. Why? Well, so the developer on call can look at the documents before waking somebody else in the middle of the night. They've gotten, naturally, JFrog Artifactory, no other artifact management system, because Baruch was co-author of this talk. But realistically, they realized that artifact management is extremely important for continuous delivery and will become even more important for them as they continue to grow because they work in this case, in payment processing. It's a regulated industry. It's subject to things like PCI compliance, DSS, SOC 2, but we'll talk a bit about that later. They've gotten this thing called Sumo Logic, right? It could have been Sumo Logic, Loggly, Logstash, Kibana to aggregate all the logs and give them a uniform search interface. Because, you know, downloading text files and using grep in Unix is kind of fun, but not very productive when you have a customer who is down and screaming at you. Wow, like, why is my service down? Right? And they've got this whole thing. They've learned from the previous incidents. They have this thing called Pingdom. Does anybody know what Pingdom is? Yes, what is it? It's a monitoring tool. As rudimentary as it gets of a monitoring tool, it sits out there on the internet, connects to the URL on your site and says, hey, are you up? And you go, yep, we're up. Because you know what? There's nothing more embarrassing than to get a call from a customer that says, hey guys, did you know your service was down? And you go, nope, thanks for letting us know. So they clearly learned from the previous incidents and they get in a very rudimentary, and that's how typically teams start with monitoring, cheap external monitoring, very easy to bolt onto your product. You expose some kind of health/health check URL that does some basic things. Maybe you put some rate limiting on it so nobody can DDoS you, but that's how typically team starts. They get a tool like that, so it's maybe 10, 20 bucks a month. It's better to spend money on that than to get a call from the customer, because nothing more embarrassing than to get a call from the customer that says, hey, did you know you guys were down? And you go, nope, thanks for letting us know. So let's see what happens at this stage from an action perspective. Remember those guys raised an A round? They hired a bunch of people. What does a startup do when you raise a lot of money? Anybody? You drink, of course. You have to spend that investor's money. That's why they've given you that. And then the usual thing happens. A call from a customer comes in. But this time the call is slightly different. Because they monitor the system, because they have the developer on call, they look at the logs, it's not nothing works. It's, hey guys, this feature doesn't work. And in our case, what happened is one of the big customers called and say, hey, listen, we ran this huge TV ad yesterday, and we're noticing that anybody who's trying to process a transaction using American Express seems to fail. Everything else is peachy, everything is great, right? Well, they call support. Support calls the developer on call. I'm sure by now you know what does developer on call do when they get a call like that? They panic, right? It's probably like a 2-year engineer, you know, first time, second time on call. Like, think about it. For those of you that have been on call, you've never been on call. It's Friday night. You're there alone in your house with a laptop. And a support guy said, hey, a big customer is screaming at me because something doesn't work. Fix it. Well, let's see what happens next. Fortunately, we have the developer on call, so the support guys don't need to wake up the entire team of 30 engineers. They know who to call. In an ideal world, by the way, if you have access to tools like that, developer on call has a virtual phone number or an extension, so the support guys don't need to know where to call. Right? They have one number, and it's the job Monday morning, typically, at least in most teams I worked on, Monday morning, the on-call switches to the next person, and it's the job of the previous person to make sure that the number is repointed to the cell phone of the new guy, because it really motivates them to repoint the number to the new guy. They don't want to receive the calls anymore, right? So for support guys, it's easy. They call the on-call. Not only that, we have a knowledge base. So the guy goes into the wiki, tries to find an issue, American Express transactions, don't process, everything's speechy, doesn't see everything. But also on the knowledge base at this stage, you have something like subject matter expert directory, right? Who is a subject matter expert on this giant system? Remember, we started with about 20 microservices. We're probably by now close to 30. The system continues to grow. So, like, where do I look? I'm a new guy. I've been here for 2 months. They just put me on call. What do I do, right? Obviously, he looked at the logs. He looked at sumo logic in their case. Nothing there. Who do I wake up? Well, we wake up the subject matter expert. So we call that. In our case, it happens to be Vasya again. The same Vasya who celebrated hard, worked on some work, and looked at the American Express recently. And Vasya gets online and goes, listen, so nothing in the logs, but there's this error from a message bus. It's saying too many messages in the queue. That's not good. What is the queue set to? Like 14. Why 14? Because we had no idea what to set for the message bus to, so we set the queue size for 14. Anyhow, we flush the queue, we fix, it's all good. Vasya remembers that, by the way, now I remember this problem happened before. We just didn't document it. So hopefully they'll do it this time. And then something new happens that didn't happen in the previous phase of evolution of the company. Friday night is over, customers are happy, everything is back to normal. But on Monday, the team gets together and does what's called root cause analysis. Some places call it post-mortem. I quite frankly, don't like that name because the patient shouldn't be dying, right? So hopefully it's not a post-mortem. Hopefully it's a root cause analysis, right? They get together, and I've seen bad post-mortems or RCAs, and I've seen good ones. The good ones, we're not playing the blame game. We're really trying to find the root cause of the issue to make sure we can fix it so it doesn't happen again. And that's why this act is called the smoke alarm installers, right? We had a fire break out in the corner of the room. We put a smoke alarm there. At least next time it breaks out, we'll get notified proactively, number one, so we can monitor for those errors. Number two, hopefully we understand why it happened. And if we do, we'll put something on the backlog to go get that fixed, right? And here's an example of an RCA. This happens from a product that I owned up until recently at CA, right? We blacked out certain fields to protect the not so innocent. As you can see, this is a typical RCA will have a fairly standard set of things like environment where this occurred if you have more than one deployment, the dates, a reference ID so they can be searchable, you have what was affected, how long it was affected. This problem lasted for like 24 hours, right? It took us a while to solve this particular problem. And then you have this thing called the event timeline, right? Bunch of things with timestamp and what happened. Can anybody guess where we got the timeline? I can tell you one thing. If you're guessing that we have a legal secretary, like you see in the movies at the court typing in the corner as we work on the issue, not the case. We don't have a legal secretary doing for it. So any guesses where a timeline like this comes from for the RCA? From logs, this is more than logs. This is what, like, somebody finds logging indicating that there's significant issues with a component called hero. So this is more than machine output. This is actual play-by-play. We debug the logs a bit, and we determine that production environment has not been configured correctly, blah, blah, blah. Any other guesses? If not the logs, yes? You're getting close. We don't do it on Confluence, but we actually have an emergency or escalation collaboration channel. We use a tool called FlowDoc because CA owns Rally, and Rally comes with FlowDoc. Could be Slack, could be HipChat, right? We like to have a dedicated room where people that are working on emergencies, and it's not one per emergency, it's like the standard place, so it's predictable. So in the middle of the night, if somebody calls you for an escalation, you don't have to log into your system and figure out, okay, which channel do I join now? Where's that error? You just go to the escalation channel or to the emergency channel, whatever you guys are going to call that channel, and you can catch up on what happened. This is where we get this because those timelines are important, because quite often this happens late at night, early in the morning, multiple people get involved, and sometimes the timeline is extremely important to reproduce the steps and find the root cause, right? Then we describe the symptoms, and those symptoms become extremely important because we put them into the knowledge base. So next time the developer on call gets a call, they can try to look for the symptoms they're observing to see if the same issue is happening again. Similarly, the support team typically will know about those, and they will see the RCAs, and they will get access to those as well, right? Then we describe, based on our analysis, what's actually happened, right? This happens during that RCA meeting. The thing about the RCA meeting, it ideally has to be scheduled within a week of the event occurring because people work on a variety of things, people go off call, people go on vacations, you tend to forget as to what happened, right? So you have to do it while the data is still fresh. And in our case, we have an SLA. It says within 5 business days of an event, the RCA has to be completed and reviewed. And it also becomes important for one other reason I'll explain. And then the most important part of the document is what's the actual root cause, right? And what are you going to do to make sure this doesn't happen again? So in our case, the next steps were 2 things. We actually logged the defect into the backlog, something needed to be fixed. And we decided that, we also had a process failure, so we amended our process, right? Why are those things important? Because however painful writing this document is, right? And it takes a while for the team to get used to the honesty that it takes to write a document like that, because everybody makes mistakes, right? I had my $50,000 one wrong typo in production mistake early in my career. I was like a developer with 3 years of experiences. I was working for the 2nd largest domain registrar in the world, and I have accidentally renewed 5,000 domains for all customers for free at $10 a pop, which was almost as much as I was making a year. That was fun. And then we had to call the customers, explain to them what happened, and roll back, and not take the money and return the dates. That one mistake generated a lot of work, right? It's embarrassing. But it's extremely important because here's the thing with customers. Customers will forgive you a mistake, even a very nasty mistake, once. And all they really care, at least the good customers, all they really care about, you figured out what went wrong, and you're going to make sure that it doesn't happen again. And this is the best way to do that. So in our case, maybe not in this exact form, sometimes in this exact form, depending on your company and your process, we will show our customers a root cause analysis document like this if they ask us, what the hell has happened, right? Why do we do it? Because it's painful. It's a bit of a masochistic process, but the worst thing as a head of engineering I get to do is get on the phone with a customer and explain how we screwed up. It's not fun. It certainly motivates me to make sure we don't screw up again. Now, remember in our case, Billy, guessed a size for the message bus. Well, in this case, they did their RCA, and they said, you know what, the queue should be at 42. Other than being an answer to all questions in the universe and everything, for those of you that read Douglas Adams, why 42? Because they have still, at this stage of the process, being reactive, they don't know any better. They don't have the tools of the process to figure out what the right size of the queue is, right? So we talked a bit about retrospective, and we talked a bit about the importance of conducting those in the timely fashion, right? Because that's what constitutes what I call a reactive improvement. Something breaks, you react, you make sure it doesn't happen again. And you would think, surely, if the company commits a felony of a great magnitude, and those of you that have seen refactoring database at scale talk many, many years ago that I did at Java Day Kiev know that the worst thing you can do to your application is to lose customers' data, right? That's a kiss of death for a vendor. Because fixing bugs is easy, you know, like if a screen doesn't work here, screen doesn't work there, customer will forgive you. You start corrupting their data, for sure they're gonna leave you, right? Or maybe not. Does anybody remember this incident? Yeah, so GitLab, right, a GitHub competitor, a major one, lost 6 hours of customer data and went down for a while. And you would think, right, this is a kiss of death for GitLab. And like I live in the Valley, we were watching it unfold live because it was happening daytime California time. It was like watching a disaster movie unfold in front of you in slow motion on Twitter, which can be fun for a certain type of individual, I admit. But you would think, right, after something like this, that's it. Well, let's look at the root cause analysis GitLab has published, and let's see how bad it was. So here's the actual RCA. Well, so there's a team member 1 who caused the issue, right? They were doing some backups. They did a LVM snapshot, and accidentally, he has deleted a bunch of data from the database. They do have regular backups that occur every 24 hours, but the team member 1 did not know where they reside. Oops. And then, by the way, team member 2 got online, and they realized that really those backups are not working because the files are only a few bytes in size. Oops. But let's not despair, because we have database backups, right? Well, unfortunately, it's the wrong version of Postgres that is dropping doing the backup, so it's uncompatible, and therefore we only get like small things. The backups are failing silently, so there are no SQL backups. And then they have this old gem that may have cleaned out all the backups as well. Oops. But don't despair, we have disk snapshot. We're a good company. We have multiple ways of doing backup, but only for the NFS servers, not the database. Oops. But we also have the replication process, but it's super fragile. It's a collection of different random shell scripts, and it's badly documented. And this time around, it didn't work. Oops. But we also have backups to S3. Maybe we'll find something there. But no, the bucket is empty. Oops. Can you imagine like being the guy who deleted this, going through this during the day? Like probably sweating bullets. Well, in other words, out of 5 backup replication techniques, none were working reliably or set up in the first place, so they ended up luckily restoring that 6-hour backup that the team member 1 happened to make, right? So they've lost 6 hours of customer data. You would think this would be like a pitchfork riot at their office from their customer base. They got lucky, and if I was the customer, I certainly would be doing this. But a lot of their customers did this, right? This is team member 1. They tried to protect his innocence. The name since then has leaked out. There's an awesome blog about team member 1 being promoted. You'll think, right? Why do you promote somebody for doing this? Google sent them some money. Guys from CodeFresh sent some cookies, right? Customers will forgive you because this honesty is painful. Everybody makes mistakes. They know how painful it is. All they want to know is you've learned something from that mistake, and you could demonstrate that you did something to make sure it doesn't happen again, right? Think about this. 6 different backup mechanisms failed miserably. And that's the typical stage of reactive improvement, right? Something breaks, you react, you do an RCA, you make sure this problem doesn't happen again. If I had to guess, statistically speaking, majority of the teams that you're representing sitting in this room here are at this stage. Because the next phase of DevOps and scaling DevOps is what we called, actually, we're not going to talk about the next stage. First, the tragic culmination of all of this, the perfect storm. Let's see what happens in our perfect storm. Well, the company continues to grow. They raised the B round and they hired 74 more engineers. They've realized that, ops is actually a thing that you need to do, and there's a discipline, and there are a set of tools and processes and methodologies that are required. So they hired 5 engineers with an ops background, and they've learned that, setting the queue sizes to 42 is not really good, so they hired this whole human being of a performance engineer, like one, because, that's make it redundant, because that one guy will never be allowed to take vacations anymore, because there's one of him. Right? They got the chief architect. And most developers at this stage of the stock go, oh, the chief architect has showed up. But the chief architect has a very important role, and we'll talk a bit about that. They got this thing called the customer success team. Remember the developer on call? They have 100 engineers right now, probably 40, 45 microservices. They have more customers. We're going to talk about customers. They should be close to 1,000 customers by now. They decided that the support teams need help, and they decided that interrupting the individual developers that are working on a sprint is not the right thing to do. So they've taken a small set of their developers, maybe 5, 6 guys, over 100, and put them into a team that's called customer success team. The job of that team is to be interrupted, so nobody else has to be, right? Because interrupts, as you all know, are very disruptive to us as software engineers. And interestingly enough, I had teams where folks would rotate in and out of a team like that. Like, maybe you work on that team for a sprint or maybe for a couple, and then you go back and somebody else comes in, because pain is instructional, right? And working on that team helps you write better software. But I also worked with some very, very talented, very senior engineers who actually hated to work on regular software development, and they loved the detective challenge, right? Because working on a customer success team is like solving a mystery of who killed the product once a day. Right? So there are certain people with certain type of personality who love that type of work, and by the way, because of that, they're beloved by the rest of the development team, because a bunch of people don't like doing that are good to keep at the core of that team, because it's an extremely important role in continuity of context, right? Knowledge of how to troubleshoot key issues in the product becomes important. They've got legal. That's also where developers typically go, ooh, legal is in the house. They hired a CFO because the venture capitalists gave them a bunch of money. They want to make sure they're spent correctly. And as I said, they have about 1,000 customers. Naturally, 100 engineers, the team has to scale as well. So here where I'm going to be using uncool buzzwords, they've adopted this thing called Scaled Agile framework, right? Scrum is great. Maybe at this stage, those guys are multi-site, maybe 100 engineers, maybe over a couple sites. But there are certain other things that the development teams need to learn how to manage in their backlog that comes out of places other than product management. Things like non-functional backlog, right? Things like RCAs, defects. How do you manage the work that goes into it, and how do you balance it? And we'll talk about why is it important. They also evolved their quality assurance methodology to create a small team called system test. Now, the job of the system test is not to test the work of everybody else. The job of the system test is to be the caretakers of best practices for testing for a very complex system. I'll give you a few examples later. The job of the system test is to advocate for those best practices and also to maintain the environments, right? The last product I've owned had a very complex set of environments that in order to run a proper integration test required certain type of data to be populated. We were identity management system. We needed environments with a couple millions of identities. The job of this team is to maintain and give it care and feeding for everything that is required from an infrastructure perspective for CI/CD to system testing to occur. We have an ops team. What? You're probably thinking, ops team? Isn't the idea of DevOps that there's no longer an ops team? Well, not in my personal opinion, because specialization exists. There's another talk that Baruch does with his colleague Mark, and they surveyed a bunch of JFrog's customers about DevOps teams, and depending on where you go, people either have a complete blend of development of operations, which I call mashed potatoes, like everything is like mashed together, or what I prefer to consume when it comes to ops team, small but chunkier groups of people, like a chunky soup, right, where those specialties and expertise are concentrated, because those guys become evangelists of what DevOps truly is in a development organization. They do care of feeding on deployment automation tools, and that's how my team was able to click a button and get an environment spun up in an hour populated with everything when we needed one, right? They take care of feeding off things like in this product that you saw the RCA from, we have this thing called the Kraken, which is a Docker Compose-based thing that creates one of the best development environments I ever worked with, that allows on this laptop for me to get all the fresh images of all the Docker containers that we have from Artifactory, straight out of the CI server, and then say, you know what? Out of the 27 microservices that we need to run on my laptop for the system to work, I'm going to work on one, shut that sucker down, open IntelliJ, click the button, and start debugging in IntelliJ while the rest of the system is automatically discovered, right? And not worry about the rest. Those are the kinds of things my DevOps team in my last product was responsible for, because somebody has to go build it, understand how Docker works, understand Compose, understand how to do the networking right. Very important team. They have this other thing called escalation pass and a manager on call. Remember, developer on call had to call somebody. And sometimes you have to call, if that person cannot solve the problem, you typically progressively call higher person in the organization, maybe with more authority or with more knowledge, to get to the resolution. You also typically have a manager on call, right? And if if a problem is of the certain magnitude, not only you wake up the next person on the escalation pass, you wake up the manager on call so they can help with communication for support and other parties. Now, a good escalation pass goes all the way to the CEO of the company. Now, let me ask you a question. Can anybody give me an idea why you think a good escalation pass should go all the way up to the CEO? I know it seems like a stupid idea, right? But normally the good ones, believe me, it does. So do. Any thoughts as to why it's a good idea? Two reasons. Number one, if the problem is big enough, right, it's the CEO who probably has to fly somewhere and play a round of golf with a customer you just upset, right? He needs to know. Number two, data indicates that if the escalation pass says, if you couldn't resolve a problem of a certain magnitude in 8 hours, you have to wake up the CEO. Typically, most of those problems get solved in 7.5 hours. It's like magic, because nobody wants to call the CEO. So the job of the CEO on the escalation pass is to make sure nobody ever wants to call him and the problems get solved quickly. Simple as that, basic psychology. They have this thing called SOC 2. So, and does anybody here know what SOC 2 is? SOC 2 is a set of standard operating controls, SOC, type 2, which is an audit standard that the service providers are typically expected to comply with. One of the interesting things about this audit standard, one of the controls that you can adopt as a company says separation of concerns. People that build should not be the people that promote. And you go, well, that sounds pretty old school, right? Development, operations, throw it over the wall. Or does it? One of the things SOC specifies is the developer shouldn't be able, or one of the ways to adopt the control, is to say the developer should not be able to violate the process and cause something to be promoted on production out of their own will. But if you have a repeatable, reliable CI/CD that says that in order for the product or for the code to get to production, those are the stages that have to be executed, right? CI has to pass, tests have to pass, maybe a performance test has to pass, maybe an integration test has to pass. Ideally, you're tracking all of that for your auditors, because you at some point are going to have to prove that you're complying with this process, maybe in your Artifactory through metadata by tagging the builds. Ideally, you're able to demonstrate the traceability of your artifact all the way from development to production. And as long as that's the process that you define, the control you adopted, it's perfectly fine to do continuous delivery without separation of concerns, because the only people that can modify the process are the ops guys, right? Ops guys set up the continuous delivery process, and they're the one in control. And if the hurdles are in place, individual developer is not able to push the build to production without some change management by bypassing the process. And that's a big misnomer about being under audit or under those controls that, oh my God, we're going to be audited. We have to have separation of duties. Developers should never push the button and nothing should end up on production. That's not true, right? Artifact and reliable, repeatable, traceable delivery pipeline is good enough for any auditor that I've ever worked with. And then they have this thing called a non-functional backlog. You can read more about that in this definition of SAFe. But in a nutshell, non-functional backlog is what the development team leadership, the architecture team, the chief architect contribute to the product development backlog to make sure things that come out of RCAs get implemented, to make sure that certain type of technical debt reduction happens, because every team accrues technical debts, hopefully for the right reason, right? Because if you're not accruing any technical debt and everything's perfect, it's likely you've never gotten to your first customer. It just doesn't work that way. So there's a separate backlog that's called non-functional backlog, and you have a well-defined understanding on how you're going to invest in making sure that backlog gets enough attention, as much attention as a typical backlog does. The tools also evolve. A couple small things. Configuration management system shows up. So, once you configure the message bus size, you can track it across your environments. And typically at this stage, you see something like application performance monitoring tools, CA, APM, AppDynamics, New Relic, etc. Something that allows you to monitor the system in a real production environment on a continuous basis. So next time you need to decide what to set the queue size to, you can look at the historical data, right? And I've seen a lot of development teams saying, you know what, we're going to write a custom piece of code to track our metrics because, we know better. Has anybody been on a team that wrote its own metrics tracking software? Okay, at least one person that is honest about that. Happens more often than that, right? This stuff, who cares? Outsource, buy those tools, right? There's plenty of stuff on the market. So let's see what happens. Naturally, like any startup that raises another round, what do you do first? Celebrate and drink a lot of wine, and then the fire drills begins. And by this time, Vasya, or Billy, got promoted. He's like one of the first 3 engineers. He's been with the company for the longest. So he is now VP of engineering. Happens, right? Remember, at this stage, the company gotten a legal guy, a lawyer. Well, believe it or not, those guys go to conferences too, right? They have meetups like this, they go to conferences, they geek out on things like IP licensing using Apache 2.0 versus LGPL, as exciting as it gets for them. So he went to one of those conferences and said, hey, Vasya, I was just at the conference and I heard about this thing called LGPL 2.2. Do we have anything in our code base that may be LGPL 2.2? Because maybe we're going to be looking at an acquisition soon, and our IP should really be clean. Well, what does Vasya do in this case? Actually, Vasya has to panic first. And then, because there's no tool in place to do anything decent right now, Vasya has to charge with the entire team of developers. Anybody been on a fire drill reviewing POM files and PM files to figure out what IP you have in your product? If not, yeah, at least 2. Yeah, happens in real life. Right? Developers have to go look for those licenses, manually aggregate them. This is where a process emerges, like every time you incorporate a third-party product, you have to submit this piece of Excel or put it on the wiki and get an approval. Otherwise, we can't release, right? That's the typical reaction to something like that. And then, of course, we have a CFO at the company, right? And the CFO goes, listen, I got to look into the future. We got to project our operating costs for next year. Dear Vasya, what do we need? How much money do we need to operate our production environment? Again, what is Vasya to do when a question like that is asked of him? Naturally, he has to panic first. Then he has to look into the sky because he doesn't have any better answers, and he has to say, well, you know what? Next year we'll need 42% more. Why 42? It's a good number. The other reason why 42, no real CFO that I have ever worked with ever told me, you know what, we're selling more customers than we thought, and you're running out of servers, but I'm sorry, you cannot have any more money. It just doesn't happen, right? You need more service within reason. You'll get it. Vasya plays the game, but he has no data at this stage, right, to predict any of this. And lastly, does anybody know who this is? Yeah, Baruch and I go back and forth, and I keep telling Baruch that if we have to explain the meme, it's not a meme. We have to take the slide out. But this is the Willard Blend guy. Has anybody seen any of the Willard Blend videos on YouTube? Yeah, at least 3 people. Basically, the guy works for a company called Blendtec. They make blenders, industrial strengths one, and he blends stuff. And he blended phones, broomsticks, whatever you can think of, he blends. In our case, the sales guys, sorry, premature slide. The sales guys come to Vasia and say, hey, Vasia, we have this amazing customer, but they're like 10 times bigger than anybody who we have successfully served in the past. Will it scale? Well, naturally, Vasia panics first. What else would you do? And then Vasia remembers that many, many years ago, he was one of the early engineers, and of course he wrote the code, and he goes to his developers and go, nope, we wrote this stuff. Of course it will scale. How do we know? Well, we looked into the sky and we believe it will scale. And then the customer shows up, and like in the movie 300, everybody dies. Right? Clearly didn't scale for them. I've been in companies like that, or been asked to join companies like that, and this is not normal. You didn't have to operate like that. Unfortunately, not a lot of companies achieved the stage that we're going to talk about next, which is Smokey the Bear, aka proactive improvement. If you guys don't know, Smokey Bear is the fire prevention mascot in US. You'll see him in every national park, on every highway. That's what kids know as, that's the cartoon that teaches kids in US to prevent fires. Don't despair if you don't see your team or yourself at this stage yet, because in our research when we did this at CA, only about 10% of the teams that we talk to, and we talk to customers large and small, reach this stage. How does that stage typically look? In proactive improvement, you do performance and scalability testing. Ideally not in the production environment. Sometimes you can't. There are products that scale to the point where reproducing the load and scale is impossible. A couple of my close friends are early engineers from WhatsApp, and at some point, you can't pump 1 billion messages a day through a test environment. You roll stuff incrementally and you test there. But a lot of people look at companies like Facebook, Google, and say, you know what, we're going to be just like them. We're going to test on production. Don't. You probably have things like license and security management. I've been traveling since June 5th. Just yesterday, there's a new bug in Linux that allows privilege escalations from user level account to root, fairly simple one, through stack collision, right? You have to monitor your libraries, your operating system, your components for known vulnerabilities, and believe me, there are some. There was a famous Struts exploit. There are a bunch of bugs in Apache Commons, and if you don't have a tool that catalogs everything you have, that can tell you that, hey, there's a fix that you need to go and upgrade. You typically, at this stage, through this whole human being of a performance engineer, or maybe a few at this stage, start doing things like proactive performance and trends review. Maybe once a week, maybe once a month, maybe some other different cadence that is appropriate for your product. You get together, you look at the consumers of resources in your system, and you start figuring out what transactions you may want to proactively work on and put some work in your non-functional backlog before those transactions get to the point where they break the system, right? That's the proactive improvement. Have you noticed all of those rely on data? You have non-functional definition of done, right? What is non-functional definition of done? Non-functional definition of done typically comes from your chief architect that says, you know what, you want to put a new component into the system, a new microservice? Well, it better write logs in a standard way. It better format logs in the standard way. Just 5 weeks ago, I've discovered that one of the components in the product I owned, or the developers that wrote it, decided that having a date prepended to the log message was optional, and we just had the timestamp. That makes it very useful when you try searching for logs, right? You have things like every microservice shall be automatically discoverable and maybe exposable to our monitoring system or instrumentable with our application performance management system. And ideally, you do it not just through documentation, but through a pattern, maybe a parent container from which you inherit that brings a lot of this stuff in. Maybe a blueprint for some of your microservice in code from which you inherit, right, that gives you some of the standard functionality. So when a new team starts, it makes it easier to scale the system and makes it very consistent, right? That's what it means to be proactive. If you look at the first 3 items on this list, there's one common thread amongst them. They all are driven of data. And in order to make decisions based on this data, you need to have the systems in place that collect this data and allow you to make those decisions. Right, you have few extra things at this stage, probably things like BlazeMeter. Anybody heard of BlazeMeter? Or any other tool that allows you to do load generation. BlazeMeter happens to be the one CA recently acquired. It's a tool that allows you to run your load testing or generate your load from the cloud. There are a variety of other competitors, right, using some kind of professional tool for load generation, because I've seen teams say, yeah, well, load testing is easy. We'll write our own. And then you go, okay, so in your scenarios, what's the distribution of think time? And you get this blank stare. What's think time? Right, think time is to allow for users, because all of us don't really click on screens in predictable ways or with predictable 102 millisecond delays, right? There's a distribution. Some people click faster, some people will take the page in, sometimes the browser loads fast, right? Using a professional tool that covers that, it's pretty useful. This one is an interesting one, and again, there's a CA product called Service Virtualization, but there are other products, and that's where the system test comes in. For example, in case of payment processing, you may have to integrate with a third-party system that doesn't give you a test system, right? Just doesn't, or it's too expensive, or it's too complex. So what Service Virtualization does is, if you think about a mock object, think of a mock service. It allows you to record interactions with third-party services, REST, SOAP, and a bunch of other standard protocols. So if you wanted to create an integrated test, but you were missing some of your third-party components, right, you can integrate with that, and you can still run your tests end-to-end against the mock service, or you can emulate certain types of errors that may not be easily emulatable. Right? And if you remember, I talked about the system test team. It's the job of the system test team to become a subject matter expert in something like that. Let's look at a few other examples. Here's an amazing tool. One of the more useful tools at the proactive stage is this amazing tool Microsoft makes. It's called Excel. It's amazing what you can do with Excel. Who has here at least once been asked by your manager, hey guys, can you please catalog or categorize issues in either defect management system or maybe an iteration management system into certain categories, because we would like to know what you're working for. Anybody in the room? At least one person is honest about that. Nobody likes doing it, and everybody thinks it's done because, like, oh, they want to watch us. They want to know what we're doing. No. In reality, what we do with data like this, and in case of my team with Riley, we can roll up our investments automatically. We can see where we're spending our time, right? How many of you have said, hey, as a team, we have a lot of technical debt in our system, but we could never get the product managers to spend any time on that, right? Happens, right? Here's what we do in my team. Myself as head of engineering and head of product management agree on our investment philosophy. We know that we need to invest in certain things, and we want to make sure that the work that actually happens within that investment envelope. So in this case, for example, and this is from one of the real products I've managed, 6% was invested into improving engineering velocity, right? Things like, hey, developers are waiting for the builds, or the pull requests are too long, or the code reviews are broken, right? We said, you know what, we're going to put about 5% of our time to improve that because there's a clear return on investment. You spend some time, you expect it to get something back. You know, few others, there were some specific customer initiatives. Then you have this thing called 34%, in our case, the bucket's called Keep the Lights On. And that's typically the bucket for things like defect fixing, upgrading the component libraries, security patching, crap like that. Another important bucket is that 5%, which in our case was dedicated to the architectural runway, maybe too low in this case, but that's what we could afford, because the best way to get ahead of yourself as a team is to allow your architect to specify that non-functional work or backlog, and have team work on things like research spikes and POCs, so by the time you go to implementing a particular feature, right, it's important to understand how to do it, and you probably get a better estimate, right? So this type of data, again, another emphasis on data for the teams that are able to achieve proactive improvement, is extremely important to understand where you're, for example, spending your development resources. And if you want to convince somebody to spend that investment elsewhere, with this data, you can have this conversation, right? I'll show you another interesting example. Let's look at this one. Another real product of mine. Can somebody tell me what a good measure for a product quality is? What can you measure if you wanted to decide on product quality? Let me take the slide away so you don't bother staring at it. We'll have this guy. So, any thoughts? What should we measure to determine whether product quality is good or bad? Customer satisfaction, great. How would customer satisfaction be exposed to the engineering team? In what form would they see that? Okay. Customer-related issue is a good one. Defects, right? So here's an example of customer-related issues from a product that I joined CA to manage. And a head of support came to me and said, you know what? The product quality of the product you just took over as head of engineering sucks. And here's why. 65% of the issues are S1s and S2s. That's a pretty high percentage, right? Severity 1, severity 2 incidents, right? The giant kind of pinchly fusion color and the yellow color. And you look at this and you go, yeah, kind of sucks. And here's the other thing you know, right? Every time the support team has to call the development team for help, the MTTR, the mean time to repair for the customer, typically goes up by 24 hours, right? Because support may work 24/7, the development team goes through triage. By the time somebody looks at the bug, at a minimum, we added an extra day to a resolution. So what do you do, right? You need data. So what we did is we decided to dig one further, and we started looking, and we asked the team, and I'm sure all of you have been asked by at least once in your professional career, guys, please make sure you set the correct resolution on the defect when you close the defect, because it's important to us. I know as a developer, all you care about writing the code and committing it and getting it through code review. But like in a defect management system, please select the right resolution from the drop-down, and let me show you why it's important. We didn't have that data, so we had to ask the team. There was about 250 engineers across 6 sites to do that, and then the data looked like that. Same data, similar period of time, and yet if you track the defects by resolution, we found out that 52% of defects were resolved with this resolution called information provided, and only 19.9 or 20% of the defects that were filed by support actually, right, caused some kind of code to be written, right? Same data, different granularity, different view, different conversation between me and head of support. What do you think is the root cause when 52.3% of your defects that end up with the engineering team, and by the way, probably cost an engineering team at least a couple hours per defect, right? What do you think a possible causes for that could be? Yes? Weak documentation or incorrect documentation. Customers don't get it. Neither does the support team, right? Because they went through the support team. What else? Let's just say not well-trained support team. It may not be their fault, right? It's the job of the engineering team. And again, I've seen engineering teams that at the end of the sprint, they dread these things like, oh, we now have to go and train support. I don't want to do that. It's wasting my time. Well, it doesn't, because it causes stuff like that to happen, right? So with data like that, I could go to my peer, head of support, and say, hey, listen, I'm happy to invest my developers' time. We'll give you better training. Let's go talk to the documentation people, right? Let's change the documentation. In about 3 times, in about 3 months, this bucket shrunk to about 5%, right? It's APM is a very complex product. This is for APM at CA. You know, we get to instrument Like it's a profile that you get to run, it's a profile that you get to run in the production environment on an application we've never seen. So on occasion there are bugs, like the people do crazy stuff, so do we. But because of the data, and again, I'll emphasize, data at the stage of proactive improvement is gold, and whatever you guys can do as developers to help make sure the data is accurate and to encourage everybody around you to use this data for decision making is incredibly valuable. So who knows what epiness is? Another Greek term. The only person who knew early on was Baruch's wife, but she is a literature major, so if she didn't know, we would have a problem. Epiness is the moral of the story. And I have three things for you if you want to scale your process and succeed by going through something like this. Number one, scale is a scale. It's a bit of a play on words, but in reality, if you notice the stages we went through together with Pentagon Inc., the work you do in subsequent stage builds on another, and it's a sliding scale of maturity. Even if you tried, and trust me, when I was younger, in some of my early attempts of scaling teams, I tried to skip stages or move too fast. It's impossible, because those things build on each other, right? If you don't have the systems in place or processes to collect the data, well, you can't be you cannot do proactive improvement because you don't have the data. If you don't have the discipline of a team to track the data, you can't do the data. And more often, that discipline comes from two places, right? You build it, you own it. And my favorite one, although Baruch does accuses me of loving it too much, is pain is instructional, right? Sometimes we as development teams isolate the source of the pain from the pain they create. And I'm a big believer, at least in the teams I run, that the pain has to come back to the source, otherwise nothing will change. And yeah, it's not fun to be on the development team that has to go through this pain. I'll give you an example. The product that I run at CA, we were going GA in April of 2016. We started our on-call process on January 6th. And all of my engineers were like, why the hell am I going on call to be available 24/7, right? Like, there are no real customers, we're not live yet, what are we doing here? And my answer was very simple. If we don't practice on call now, and boy did we find issues in our process in those 3 months of practice, we're going to be practicing on our customers, and that's not what they're paying us for. They don't deserve that kind of experimentation. We will have plenty of other bugs and other issues to experiment on, like any new product that goes live. So pain is instructional, and what I've learned is sometimes a bit pain is okay, and like, you know, those of you that love sports and running, you know, pushing yourself is kind of painful. Like, you go for a long run, it is painful if you're doing it, or if you're pushing yourself beyond the boundary, but you get better through that. With that, I can answer, how much time do we have for questions? That's a dangerous proposition. I can talk 4 hours. And I can talk about this talk, happy to answer questions about Silicon Valley, whatever you guys want to ask. Or none, it's up to you. Hopefully Andre prepaid for at least one question, so it's not embarrassing. Or maybe not. So, any questions? I can tell you, by the way, Odessa already outdone you guys. In Odessa, we talked for at least half an hour. It's a challenge. Yes, first volunteer.
Have you ever faced with resolving security and if so, what is the steps?
So have I ever faced, yeah, so my last gig at CA was head of SaaS engineering for a security business. So kind of security is what we do. A couple things. If you want to be proactive about security, you have to integrate security into your development pipeline. Actually, CA recently acquired a company called Veracode. There's another competitor called Fortify. Being proactive typically means, in addition to doing code reviews with somebody who understands it, and we have to because we are a security vendor, so like the standards for us are even higher. You want to do it as a continuous process. There's this industry push for what's called DevSecOps, right? Because things are moving faster and security is becoming more prevalent with all the breaches that are happening. Ideally, you want to integrate security into your CI process. And there are two spots where you want to do it. nightly, you probably want to do a vulnerability assessment using static code analysis or binary analysis using tools like CA, Veracode, or Fortify. In addition to that, what we do at CA, we use GitHub Enterprise in-house. Our pull requests are hooked up to SonarQube to enforce static code analysis rules, right? All the code guidelines, formatting, like don't open a connection outside of the try and forget to close it and finally, like basic stuff like that. But you can also hook up static code analysis for security vulnerabilities to your PRs, right? In our case, SonarQube and prior to Veracode, and we're looking at how we're going to do it with Veracode, Fortify would actually go and write comments right there in the pull requests. And you would have to go resolve them before you can close, right? And that ensures continuous security. One challenge with static code analysis tools like Fortify, compared to, for example, something like Veracode, is they have to look at the source, so they tend to produce more false positives because they don't always understand the context of a particular file in the larger binary. When you do a binary security analysis, the engine can look at the data path and understand how the data can reach you, right? And is it a false positive or not? But the two best spots to do that from a continuous perspective at the code level is nightly CI at the minimum, and ideally you have something at the pull request level. So that stuff is gets caught right there, because that's where it's the cheapest to fix. The moment that defect escapes, it's exponentially more expensive, right? On the tail end, you do things like penetration testing, either using automated tools like AppScan or White Hat or a bunch of other tools that will do kind of black box testing. You probably, depending on your risk tolerance, want to do a manual White Hat penetration test by like a real security analyst. And at the early stage of the process, as part of your artifact and build management, you probably want to have some kind of system, again, Artifactory plus Black Duck or JFrog X-Ray, that monitors the components you have and can advise you about non-security vulnerabilities that may have discovered in those components. So if you're running whatever, Apache Commons Lang version 2.2 blah, and there's a new bug, you get an alert, goes into your non-functional backlog, defects gets opened. Those three areas, artifact management, code management, and kind of proactive testing, those are the three I would consider. Cool. Yes? Which tool, so the question was which tool you use for managing development. I've seen a variety of solutions. I played with a guy like with product called CodeFresh. It's an interesting approach. We rolled our own, like our DevOps team, and it was a tiny DevOps, there were like 2 engineers for a while, now there are 3, grew up by 50%. They wrote using Docker Compose, our own development set of tools, mostly convention plus data, and the tool is called Kraken. It has 3 major capabilities. It integrates with our artifact management system, so as a developer, I can do like I think our SLAs for switching branches was 5 minutes. And we're a multi-site development team, but we do have Artifactory spokes everywhere, so the binaries do replicate. So chances are you're downloading something from a server that sits right next to you. So we don't rebuild the containers. We, using that tool, are able to bootstrap an entire system. So we are, for now, fortunate enough to live without any dependencies that we cannot Dockerize and fit. And this is a 3-year-old MacBook Pro with 16 gigs of memory, and I can still run this thing in the developer configuration. And then the third capability of that system for us was important for us is we wanted it to be tailored to a particular developer type. So we have UI engineers. It's a single page, thick JavaScript app. They don't care about anything. They just want the servers to run. So for them, they have a special mode. They start it up. Everything starts up. We have a couple tenants populated. Data is there. Everybody has the same data. And they have a place where they write the code. They point the browser. It works. For the guys that work on the back end, they say, hey, I want the entire system, but I'm going to be working on the scheduler. Scheduler gets shut down in Docker that runs inside the container. We actually use Docker for Mac. In addition to Docker for, like, we have 2 modes. We have a VM for the, like, we have a set of developers who like to develop in a VM, including the Docker, and everything runs in that VM, and that VM gets built, again, on CI, If you're a new engineer, you just joined us, you download the VM, it actually has IntelliJ pre-installed with the right licenses, with the right configs, all of that's out of the box. Or if you're like me, I hate running an extra VM, I have Docker for Mac. So I can say I'm going to work on the server, shut that server down. The configs for Eclipse and IntelliJ are generated such that all the port mappings are set up. I can click debug. It will spin up. It will discover the rest of the services. We do it through port numbering, like we just know what sits where. And I can develop while the rest of the system is running. So that's the environment we use today. Having gone through a variety of iterations of the last 20 plus years I've been doing this software engineering gig, this is the best I've seen. Because you have the entire system, no shared components. I can work on an airplane if I wanted to, right? Because I have everything with me. No. We are thinking about either monetizing that because CA sells IT tools and we have some know-how. We may monetize it as a product. We may put it out, but again, it's a collection of YAML files and Docker composed in some basic glue. It's not, and like a bunch of Ruby. It's not very complex. You can probably reproduce it in less than a week. For configuration management. In dev QA stage, and by the way, we use this environment. Kraken is awesome in the way, but because we have full automation, because we have a DevOps team, we do pull request builds for product managers. You do a pull request, you go to Jenkins, put a number in, it spins up an environment, populates it with data, sends an email to a product manager or PO, says, hey, click on this URL, accept this story. When you click on the URL, when you accept the story, marks it in GitHub as pull request, PO accepted, shuts down the environment, because like we can spin up and undeploy the entire system. This team has not evolved too far yet. It's a product that is a year and a half old. So configuration management is mostly YAML in pre-prod, and in prod there are a few other things, but there's nothing sophisticated yet. It's on our non-functional backlog because we do have a chief architect who said, hey, maybe it's time to look at some configuration management, because we did have a couple of those RCAs, by the way, I think including this one that says, hey, system was misconfigured, not a good idea. But unfortunately, it's low on the priority list in the non-functional backlog. We have bigger fish to fry right now. This product is like first 10 customers. We still need to get them successful before we can start, decorating the house. First, we need to make sure the roof stays in place, the wind doesn't blow the roof away, so no configuration management yet. Yes? So right now we use a mix. This product, when I joined the team, was using Beanstalk. We CA are big enough of a company, and sometimes we have to operate in places where AWS doesn't exist. Or for example, we sell to federal government in the US, and there is AWS FedGov, except that it doesn't have every single service that AWS has yet. They're catching up, but for example, a year ago when they launched it, SNS wasn't there, and a few other basic services. So we actually, as CA, are shifting our strategy. Oh, I shouldn't say as CA, I'm no longer with them, but CA is shifting to OpenShift. We like OpenShift for a variety of reasons. Most important, we like it for environment portability, because we can deploy OpenShift in-house. We have some of our own data centers because we have few PCI DSS compliant businesses, so they run in this fancy cage with lasers and machine guns and whatever else you need to run PCI DSS cage. We have stuff running on Azure, we have stuff running on Amazon, we have stuff running in a variety of data centers throughout the world where AWS doesn't exist. So we've chosen OpenShift because of the portability, as well as because how densely OpenShift can automatically pack microservices into hardware and you don't have to worry about it, because AWS can get expensive. And from a strategic perspective, OpenShift is good for us because I know when we, for example, as a company upgraded to Office 365, not only we gotten the licenses from Microsoft, we also gotten a chunk of money to spend on Azure. And we want to have our workloads be portable, and if we feel like we want to run this thing on Azure, we have a SaaS operations team because CA has 3,500 engineers. We have a centralized SaaS operations team that does that kind of stuff and much more, like compliance, RFP, RFI responses, auditing, securability testing, OS patching. They prepare our standard hardened Docker images, standard AMIs, all that crap, so we don't have to do it in every team. We value that level of business portability, so if tomorrow AWS gives us a better deal, we're just going to shift the workload to AWS, right? So OpenShift is where we're going, but we haven't moved everything yet. It so happens that we also have, as a company, a partnership with Red Hat. It was not the only answer. We did a deep technical evaluation. It's obviously a consideration. We do like to work with our partners and resellers. But in our case, OpenShift satisfied the specific needs we needed. And if you think about it, CA has 250 products. At least 30, 40 of them are SaaS by now, right? We needed something that gives us a uniform way that is for packaging. The other consideration we had when we looked at technologies, we also have to hire people. And like I had people that say, hey, I don't want to work on this technology or another. Like, it's not the most important thing we do, but we needed to build a sizable SaaS operations team. We needed to pick a technology that has career opportunities for folks, because every once in a while they leave CA and go elsewhere. I don't have all the details for you. I can tell you one thing we don't do. We don't use their password management for one simple reason. CA has a product called Privileged Access Management, part of our security offerings. If you want to kind of get the gist for what the product does, it's the anti-Edward Snowden use case. It's the product that watches the system operators to make sure they don't do anything they're not supposed to be doing. And for example, if you venture into an area of the system you're not supposed to be in, we can re-authenticate you, record your session, kick you out, variety of things. One of the products we sell. As part of that product, we have a very interesting pure play software password vault that is done using white box encryption. White box encryption is the kind of encryption that is designed to be observable without being able to extract the data out of it. And we do that because it gives us the portability without having to use what's called HSM, hardware security modules, because AWS offers HSMs. For those of you who have seen like smart cards, right? You put your keys on a smart card, it's very difficult to extract. You have to go to the data center. You have to wake up 2 or 3 people in the middle of the night if you want to restart the sucker, because not everybody has the entire password. We get to avoid all of this, plus we achieve full portability because we have some IP at the company that gives us this password vaulting as a pure play software solution. And it's hooked up. What else? I can answer questions about technology, Silicon Valley, I don't know. By the way, the common question, if you guys are watching Silicon Valley, the HBO show, how real it is, it's about 80% real. I haven't watched the last 5 episodes, I've been traveling, but like, let me assure you right now, I live out there, it's about 80% real. The question was, what development methodology do you prefer? Quite frankly, over my 20 plus years of my career, I've developed products using a variety of methodologies. Accelerated waterfall, RUP, Kanban, Scrum, SAFe. Depending on the size of your team, I think different methodologies are appropriate. Like if you're small, Kanban is perfectly fine. At some point, Scrum is probably the best thing, and not because it's better and kind of, for those of you that aspire to go into management one day, there's a certain point in your career you're going to stop reading technology book and you're going to start reading psychology books. I'm not kidding, that's happened to me. If anybody looks at my list of books on Goodreads, like there's a very clear stop, and then there's like a bunch of psychology books. Because being in management is like running a kindergarten sometimes. Or for those of you that are maybe already parents, it's like dealing with kids. But the reality of Scrum is it allows you to achieve the same outcome with what I would consider better team buy-in, right? Because at least it's perceived to be more democratic by the team, right? We use SAFe today, even though the team I'm working on is only 38 engineers. We like SAFe, and we like several elements. And you don't have to adopt the entire SAFe framework. It's a giant framework with a variety of things. You can adopt it incrementally. But I'll give you a couple elements of SAFe that we really like. So we run on a quarterly, we release them to production at the end of every sprint. This is a security product, so we decided that continuous delivery was not appropriate. Nor would our customers tolerate that yet. They kind of, SaaS and security are kind of at the later stage of adopting SaaS in general. SaaS is being adopted for security products, but our customers are not quite ready for continuous delivery. So we release at the end of every sprint, but we do planning in what's called program increments, which is a term defined in SAFe. In our case, a program increment runs a quarter, right? At the end of the PI planning, we do two things that I really, really find useful for us. We do a confidence vote, right? Where we do what's called a fist of five vote. Everybody gets to vote, and there are one of 5 stages. 5 is like, this is the best plan ever. This is a decent plan, which is 4. 3 is like, it's a good plan, I have some concerns about it. 2 is like, we have some real concerns about this plan as we laid it out in our planning system. I don't think we should go with it. And 1, there's like no freaking way. And quite frankly, more often than not, and actually we did a PI planning in May, and for the first time we had 2 twos. Like 2 people on the team, when they voted, said, you know what, I'm not comfortable with the plan. And we had some really, really good conversations. And more often than not, you have a conversation like that. We typically like to talk to 1s, 2s, and 3s to understand what concerns may have not been surfaced. We actually, for the first time in my professional career, went ahead with the plan because we decided as a business we're willing to take a risk with 2 people that still stayed at 2, saying this is a bad plan, we shouldn't do it, right? So that's one exercise I really like from SAFe. The second exercise I like from SAFe is called Rome. Anybody heard of Rome? So the idea is, as the team is doing its planning, and if you want to look up both of those exercises, go to the SAFe website, safeframework.org, I think, or you can Google for it. What Rome does, it allows the system to surface the risks as we go through this planning exercise. Typically goes for 2 days. Like the ceremony, first opening, myself and head of product management do a strategy update for the team. Then we talk about the features. Then we break into sprint teams, scrum teams. They do their own planning. Then we come together, we look at the plan. That's typically first day, we sort interdependencies and timing. Second day, if we need more time for grooming and planning. During this process, teams will use sticky notes and will catalog all the risks they identify, right? I don't know. This component needs to be, depends on that component, it's not clear that we're going to get delivered, or there's a lot of unknown in this feature, or this component is unstable and we're about to do something major to it, stuff like that. Excuse me. At the end of that exercise, we look at every risk and we assign them to 4 different categories: resolved, owned, accepted, or mitigated, right? Resolved means that by the time the event of the planning has concluded, we figured out that it's no longer the risk. We may have rearranged the schedule, taken something out of the backlog, rearranged the work, whatever, right? Mitigated means like, yeah, it's a risk, but we have some kind of mitigation strategy. For example, the system has not been tested past 10,000 concurrent users. Well, the mitigation could be, we will not allow the sales team to sell past 10,000 concurrent users. Valid mitigation if you stick to it. Third category is owned. Yeah, it's a risk. Somebody has to work it, right? Typically one of my directors, either head of DevOps or head of one of the development teams, maybe head of system test, or maybe myself or head of product managers. And then there's accepted. You know what? We heard you guys. It's a risk. If shit happens, shit happens. But it's amazing how much easier it is for the team to realize that it's an accepted risk and we can just take it out of our mind and stop worrying about that. And one other thing we do with the Rome is the program team, which is all the key leaders and the SOS, meet once a week for a program call to review the progress of the program. We look at all the usual things like quality, burn down, all the standard stuff you would look at. Every 2 weeks, we review the Rome board. The Rome board in our case is in Trello. Everybody can see it. We update it. So every developer that cares about the risks they've created, and because they created the card, they get notified every time we update the risk, sees that we actually not just do this for the sake of this, let's do the Rome exercise and move on. We actually actively manage those risks. And what I found useful from at least those two elements of SAFE, it creates an amazing buy-in by the team, right? Because it's not us against them, the development team versus the management team. It's all of us together. We just have different roles and responsibilities in the process of the program increment. So we run SAFE. I'm quite happy with SAFE. I've seen badly adopted SAFE. I've seen well adopted SAFE. Some people think you have to adopt the entire thing. You don't. But there's some very useful elements. And the other thing useful about SAFE, and then I'll get off my high horse on that, is a lot of teams tend to invent their own process and document their own process. I've been in this movie. I managed about 10 different development teams. Everybody has their own process, and it gets old, right? If we want to look what a good retrospective is, go to the SAFE website, well-documented set of things. If you want to know what a Rome exercise is, well-documented. If you want to know what a inspect and adapt workshop should look like, right? Let's stop reinventing the wheel, and that's one of the reasons I like SAFE as a framework. There are a few other competitors to SAFE. Just like point to something that exists and document it. It's kind of fun to reinvent the wheel, but it's not very efficient. SAFE is something that builds on top of Scrum, right? Like the framework of program increments with multiple sprints inside. A concept of planning an innovation sprint, right? Every quarter we have a sprint that is planning an innovation sprint. That's where we finish grooming. That's where we do a FedEx day, and that's when we do PI planning. A concept of architectural runway and the role of the Scrum team architect versus chief architect is well described. So it's a next layer of complexity on your typical Scrum. It's still regular Scrum underneath. As far as the developers are concerned, what you see every day is Scrum, but it helps manage a collection. And I've managed large teams. It just helps manage this mass of people working on a program that gets complex. Now, it does require one thing and works better in professional software development companies because it does require professional product management, right? You have to have product managers that are fully trained as product managers. You have to have POs that are trained as product owners. If any of those key elements are not there, things tend to fall apart, and I've seen a lot of people attempt SAFE without doing that. Like the new team I took over said, oh, we don't have enough POs, but that's okay. I'm like, no, we have a standard ratio with like 1 PO, 2 Scrum teams, and next time we have an open rec, instead of hiring an engineer, we're going to hire a PO because we're not doing anybody a favor, right, by not working. Like changing requirements is cheap. Like we can rewrite the story 15 times and spend like 1 hour. Changing code is exponentially expensive after you've written something incorrect. So like a lot of people forget about focusing on the beginning of the pipeline, and like things like SAFE help with at least best practices for people who are doing it for the first time. Anyhow, enough about SAFE. Any other questions? Yes. Yes. I'll give you some of the data. Some of the data I can't, because a company would consider it confidential. Some of the data I just don't know. So we settled on Kafka as the underlying substrate. We have a lot of stuff that uses Akka. We like the integration of Kafka and Akka together. It doesn't hurt that I know Conrad, who is working on the Akka team at TypeSafe, so when we need help, I can just call Conrad and ask for help, which we've done once or twice. So we've standardized on Kafka as the message bus. Works quite well for us, especially when you use it in combination with Akka and Akka streams. Load testing. We do some proactive stuff in our lab using tools like we own, like BlazeMeter. I don't remember the data and to what degree it scales, but Kafka scales reasonably well. I know Raleigh is running Kafka underneath, and they're pushing a lot of messages without any issues. And the way we approach the methodology of testing, maybe not on this product, it depends on the stage of the product, but if you have a later stage product where continuous improvement, where you achieved continuous improvement or ideally proactive improvement, I have a big controversial approach that a lot of my peers don't like, is I don't believe in performance testing in the lab. It's just pointless. You can never reproduce the environment or the workload or the characteristics of the workload. There are exceptions to every rule, of course. So my personal preference, if I have the money, because as a head of engineering, I'm giving a bucket of money. And if I can spend that bucket of money on instrumenting the hell out of my production environment and spending my development time understanding what's actually happening in production, rather than trying to simulate some fake load and like fix problems that may never exist, right? I would rather spend money on instrumenting the production environment, looking at concrete problems in the production environment and fixing them. Has anybody here seen my talk, 3 years ago on performance tuning? No, okay. One of the key things in that talk, if you think there's a performance problem in there, 99.9%, unless you're Mr. Shipilov, you're probably wrong. And even he does harnesses and tests, right? Because doing performance optimizations or scale testing without concrete data is absolutely a fool's errand. Ideally, you have a tool that not only says, hey, this is a microservice that is a bottleneck. Ideally, you have a tool that instruments your code all the way to the code and can point you to like, this method is the hotspot. Right? When I was working at Taleo, I was AppDynamics customer number 3. For this reason alone, I'm still a talking reference on the website somewhere, because what we loved about that tool, straight pointer to like, this is the method that is the hotspot that has too many iterations through it. Go fix that, right? More often than not. So my personal preference, and don't take it as gospel, I've seen people say, hey, I heard this is a bad idea to do performance testing in the lab. We should only do it in production. No. It's situational, but if I have a choice, I would rather instrument and spend money on instrumenting production. Okay, let's do one last question if there are any, and then we'll get out of here. I have not listened to the last episode of Razbor. And by the way, for those of you that are listeners of Razbor Palyotov, there's an episode with me 2 episodes ago. Thank you for setting me up for a shameless plug, where we talk about angel investment, Silicon Valley, engineering, and all other unrelated stuff for like 3 hours, I think we managed. From what I've seen from comments on the episode, I can tell you that one of the challenges I've seen with technologies that emerge, it's very difficult for them to be adopted at professional scale without tooling. And I think one of the things that Kotlin has for going for it is the fact that the company that builds the language also builds the tooling, right? Because I used to hate JavaScript I would have to touch JavaScript as a software engineer, and I used to hate it with passion, right? Until my favorite IDE of nearly 20 years, not 20, actually 15, IntelliJ started doing smart things. Like IntelliJ made coding in JavaScript tolerable for me, personally. So I think, and I think similar problem was not like for things to get adopted at scale, at really big scale, you need tooling support, and not just not just development tooling, instrumentation. Like there was no decent APM solution for Node.js for a few years. Like it's awesome that Kotlin will be there, but like we talked about load testing or not load testing, instrumenting in production environment, unless the runtime environment allows you to find the method and pointer into the code when you're running on production. Like in my previous product that I was talking about, we had Node.js, kind of event-driven code, and Akka, Java-based Akka, not Scala, just so we're clear. Driven code. One is much easier to optimize because the bloody JVM is rock solid and it has tools. And then there is Node and no tools. So that's my view. Languages are interesting, but code is cheap. Writing code is easy. It's supporting the bloody thing in the production environment under load that is difficult. And with that, I thank you for your time. If you, again, want to find me, Baruch is at jbaruch. All the bad things you should tell to him on Twitter. All the good things about this talk, you can mention myself at Igolnik on Twitter. The slides of this talk, if you ever want to see them, we'll give JFrog another plug, jfrog.com/show notes. Baruch and I have done this talk many, many times. There's at least one video recording there. I'm sure there will be this one, and the slides are there as well. Thank you very much.